welcome everybody. I'm excited for this session today. We're going to talk about Temporal Cloud and some of the challenges and the way that we deal with them from an availability, disaster recovery point of view. So this should be a great session. This is part of a Tech Talk series that we're doing around Temporal Cloud. We get lots of questions around, all these various different components of Temporal Cloud and how do we do what we do. We held our first session, gosh, it feels like a long time ago, but it was just last week. I know that recording is available. Today, we're talking about availability and disaster recovery. I'm really looking forward to the session next week, where we're going to talk about the persistence layer that we built for Temporal Cloud, using the same storage API that we allow you to use with a Temporal service today. Talking about pricing and actions and how do you think about costs, and then last but not least, if anybody's interested in migrating. So this is a series. Feel free to use the QR code or the URL over on the left-hand side if you're interested in all or one of these. We would love to have you join. I hope these are valuable. With that, let's get the show on the road. So I want to invite Liang and Nikitha on quickly for our little quick intros here. Hello, Nikitha. Hello, Liang. How are you both?
Good, thank you.
Oh boy, Nikitha, you need some water over there.
I know the weather here has been a bit sketchy, but good to be here.
Yeah, I know you've spoken today, though, so that's the funny thing. Well, welcome both. Liang and Nikitha, I know you're both deeply involved in everything that we're doing, to deliver kind of a highly available, kind of reliable service of Temporal Cloud. But Liang, can you just give a little background of kind of like what team do you work on and what do you work on here at Temporal?
Sure. Here at Temporal, I lead team which works on this new feature called Global Namespace. So basically, we're trying to give our users a better availability from 3.9 to 4.9. And underneath the hood, we're working on the whole replication stack in the core Temporal server side of things, plus all the control plane traffic routing and the failover protocols when disaster happens.
That's right. But Liang, you've been with Temporal for how long now? 3 years?
I've been with Temporal for a bit more than 2 years, but I've been pretty involved in the early Cadence, Uber Cadence days, and I've run the Cadence team for quite a while before I joined Temporal. And back even at Uber, we've been running this whole replication stack and sort of filling over namespaces from time to time. So
that's great. Yeah, thanks, Liang. And so anybody, if you have some deep questions about Temporal and how to run it as a service, I tell you what, you have one of the best minds on the planet for doing so. So again, questions, QA, everything available. Nikitha, you're on the other end. You're relatively new to Temporal, right? What team are you on and what are you working on?
Yeah, it's been 5 months so far, very fun 5 months. And I'm on the product team. I work very closely with Liang on availability, global namespace, the feature that he mentioned, and we'll talk about more today. In addition to that, I'm also thinking a lot about worker management and deployment, our self-hosted to cloud migration, basically just making the experience of using Temporal easier for our users.
That's great. 5 months is, man, I feel like it feels like a lifetime ago, but also yesterday, Nikitha. You've done so much work here since you've started. So, y'all, I'm Jim. I am your MC for today, and I'm honored to work with both of these individuals. And so I hope this is valuable for you today. So we just want to talk about availability and these sort of things. And so, Temporal is a little bit of a unique approach to building applications. We have there's kind of two pieces. There's an SDK, which you kind of you build workflows, you build activities, and then the SDK works with your application via workers and whatnot to connect to a Temporal service. And that service can be self-hosted or it could be run in you could just use the managed service of Temporal Cloud just to kind of give a back end kind of like bigger. And I know everybody here knows what those things are, but we're really talking about, the things that you have to do with the service itself to make it more, available and reliable. I think, Liang, we could talk a little bit about workers and some of the things a little bit later, but like, what are some of the unique challenges, Liang, in terms of running, the service itself, either self-hosted or cloud, the stuff that you've been working on? What are the key things that people should look out for?
I guess let me take maybe one step back, right? Let's even try to admit, like, designing and implementing a complicated service like Temporal is a very challenging thing, right? I mean, when we started this whole project, the whole value proposition is that people use the project so they don't need to worry about reliability problems, which means that as soon as they start to develop on Temporal, then Temporal service availability basically is in the critical path of their application availability, which means that when Temporal server is down, anything is down. Again, back at Uber, like Uber Eats relies on Temporal. So, I mean, like Cadence back then, but which means that when Cadence has issues, then all these applications has issues. So from that perspective, there are enormous effort that's been spent over the past more than 7 years, right? We start with all these different use cases and tests and all these things. And even recently, we will continue to improve that part of things. Like recently, we had this incident where we noticed that there is this matching service restart actually impact our long tail scheduled start latency for some of our customers' workloads, and then we actually root cause it and we fixed that bug. Right. I want to just start with there to just give people an idea, like designing and implementing that service is very hard. And then I think, as you mentioned, then there are a large part of this obviously is the operational side of things, and also how to deal with our dependencies and in the infrastructure we use to provide this service. As with all these modern applications, right, you're basically dealing with sort of network, compute, and the storage, right? And if you look at all these different things, they have different failure modes and they have different impacts. I think Temporal being sort of event sourcing system and durable event sourcing system, it means that storage probably is the most important thing that it relies on. So from two angles, right? One is obviously when our storage systems is not available, then it basically propagates all these error back all the way into our front end, into our workers and users. And that's, I think, why the next session, which deals with all the persistent layers, is going to be very relevant, like when they talk about like how they handle all these different errors. And then other than that, like compute is relatively easy, give the assumption that we have enough resources, right? Temporal, with all these modern like application designs, it has all these ownership modules and everything, which basically deals with nodes going up and down, and the system basically itself can handle all these scenarios. Network is also pretty hard to manage, especially if you look at network partitions. I think network partition is the most complicated thing to manage sort of in a distributed consensus space. So Temporal actually spent also a lot of efforts to sort of look at these different scenarios, make sure that we do the right trade-off between consistency with availability, and you'll hear more about this when we talk about failovers and replications.
Wait, when you talk about network and some of the challenges there, Liang, when you mentioned network partition, some of the things, are there challenges that are explicit to Temporal? Is that just kind of in general when people are building services, you kind of got to look out for it?
I think this is some problem that is general enough that everybody should be aware of, at least. And I guess the good news is that Temporal abstracts all these problems. So as a developer, it's sort of like you will need to understand the problem, but you don't need to deal with it by yourself. So by using Temporal, and especially our replication step and global namespace, as a user, you should understand what happens if there is a network partition happens. But Temporal will give you a programming model and a few of these instructions that helps you navigate through all these things. You don't need, as a developer, you don't need to write the most complicated code to handle all these different error conditions, conflict resolution schemes, and any of these. And Temporal does all these heavy liftings for you.
Right. And another key piece there is kind of the gRPC gateway and that sort of stuff, if you choose to go down that path. Another area, and I think we will talk a little bit about that as we kind of get into the next section, and how do we measure kind of what availability is like?
Right.
Let me actually, Nikitha, I'll throw a quick question into you. How do you define availability for kind of Temporal Cloud? I'm not talking about the exact numbers, but like just what does that mean? You know what I mean?
Yeah, absolutely. I think there's like several different ways you can look at it. In terms of just like regional availability, we're available in 12 different regions. And I think that in itself is kind of one layer. And then we also publish certain latency service level objectives of like the kind of, you can expect up to 200 milliseconds per region, which is fairly performant. Other than that, we also have what is commonly known as the 9 model. So we offer to all cloud customers 3 nines of availability. And the way in which we're measuring that is, calculating the service error rate. So we want to make sure that all the requests that are arriving to Temporal are being responded to. And so the service errors are what count against that SLA. And in most cases, like we're doing really well on meeting that SLA for our customers.
Yeah, that's great. And so let's actually, I want to go into that a little bit. You guys, and so Liang, I know we've had conversations about this before. We're measuring service errors, correct? I mean, this is basically we're measuring things that kind of fall down at the gRPC layer. Is that correct?
Yes, that's correct.
Yeah. And so this isn't like the service is available. I think sometimes people mix up like, hey, I could ping the endpoint. That's simple. This is different. This is like the actual service itself. Is that correct?
It is correct. So I think, as you mentioned, I mean, even we actually look even in more details because if you know Temporal enough, you know that people actually care very differently about these different set of what we call APIs. Like people have a very high expectation for example, for starting a workflow, for signaling a workflow, for any of these APIs which require a direct interaction with the client. And then the next set of category is sort of the worker pulling tasks and everything. Like it's a little bit more tolerable because the worst case scenario, your task will get delayed a little bit. And in some cases, it's okay for customers. And then the next set of them is like visibility and all these. And the last probably is what you call the pings, which yes, will make sure that it's very easy to achieve like 4 nines, 5 nines availability, but that's not going to deliver a lot of value if the other APIs are not available.
Yeah, that's
so
great.
we look at all these things.
Yeah, and that's right. And Julian was asking a question about this too. So actually, Julian was asking us a question. Is it 3 nines? Is it 4 nines? Look on the Temporal Cloud webpage, like the marketing website, y'all. There's a lot of detail underneath that. If you go into docs, if you really want to like explore how we do this, we try to publish as much as we possibly can, and we're getting better. And we're gonna publish a lot more. Julian asked the question of 3 nines versus 4 nines on the cloud page on the marketing site. We actually say both of the numbers. We like pinging the endpoint is like 4, but the service availability is 3. We'll get a little bit more clear on that. We've heard a couple of other kind of like questions about that. And so Julian will address that on the website. But I wanted to explicitly call out the difference between those two things because, hey, I thought I was going to get that question anyway, Julian. So thank you for asking that. So yeah, I think the most important part is, and correct me if I'm wrong, Liang, our SLA, which has like a money back guarantee, is based off of the 3 nines for service availability, correct?
That's correct. And if you want
Yeah.
4 nines in that category, I think Nikitha can talk about the global namespace feature.
That's right. That's right. In that category. So we actually back it up with a guarantee of, we'll pay you back for the time that we weren't up. So we take it pretty seriously, y'all, because I think of Liang's very first point, which is the whole point of Temporal is reliable, durable application. So like the thing's got to be reliable. So last question kind of in this section, y'all. What do we think about? Do we talk about RPO, RTO internally, externally? How do we think about that, you guys? Nikitha, I think, do you want to answer that one?
Yeah, I think it's something we've been thinking about more and more in the context of global namespaces, because I think that level of kind of reliability is expected with a feature like that. So perhaps maybe once we dive into what that feature is, I can expand a bit more on our thinking about that.
That's
so
great.
let me just add one thing in here. So I think as of now, without global namespace, we do have some targets for RPO and RTO. I think that is with our storage providers, because I think it's in the order of like 2 hours or something like that when we can restore the data if we really want to from our previous backup.
And that's RPO really. So that's great, Liang. So we'll get into a little bit more at global namespace because I think there's some things we're doing there that get really interesting for kind of these higher end, deeper kind of requirements around availability. So let's talk about how we do this then, Liang. What are all the pieces that we're doing to get this kind of service availability? And remember, 3 nines is it's actually there's a fair amount that goes into that. So Liang, what are all the components there?
So I think in general, right, when you need more availability, you will need 2 things. You will need redundancy, and then you will need a process which you can handle all these failures in a sort of professional and timely manner, right? So not sure like what the global namespace does, right? It adds redundancy by shipping out all these what we call history events from a region into a different region. Right, and then we develop this failover process, in which like we can click a button, and underneath too, there's actually a control plane workflow, which does the switch of your active and standby processing logic, so that when reading goes down and your current existing workflows can basically continue their execution in a different region.
That's great. I was just typing back to somebody that asked some deep questions. So it's redundancy, but it's also kind of like, isn't there kind of like a balances? Like, I mean, there's trade-offs, right, Liang? Like, I can give the most reliable service in the world if I'm willing to pay crazy amounts, right? Like,
right. There are a few. I think in dealing with all these different error conditions, trade-off is the key question that everybody needs to sort of think about and answer, right? There's the sort of technical and obvious trade-off between availability and consistency, basically the CAP theorem that everybody knows about. And there is also this sort of more intrinsic sort of trade-off between complexity, cost, and the additional nines. Right. Usually, as you get more nines, it becomes exponentially complicated and costly to get those nines. So as the application developer, you should think about whether it makes sense for your business and for what use case it makes sense, right? Even back at Uber, when we have more than 2,000 namespaces, it's not like everybody cares about this additional 9 with the cost that it brings in. And the third part of this is, as a software developer, like you will need to think about end-to-end sort of availability. When you run your workers along with Temporal Cloud or even your self-host Temporal server, you need to not only care about the server side availability, and you need to also look at your worker availability and your dependencies availability. You need to make sure that all these things align so that you can achieve whatever the eventual goal that you deliver to your customers. Having one of these services providing 5 nines and the others doesn't, is not going to help you.
That's right. And it's interesting, Liang, like ultimately there's no such thing as 100% availability. I'm sorry. And I'm happy to have this existential debate with anybody, but like, there's no such thing on this planet. Everything failed, right? So like, it's always kind of some diminishing return of money and time and complexity that you want to spend to get to as close as you need to get to basically make your business work. You know, I mean,
yes, that's correct. And Temporal want to be part of this because we believe that we provide the best way that can help you and guide our developers to go through this difficult times.
Yeah. I mean, I hope our nuclear codes and those sort of things have a lot of redundancies. I'm sure they do, but that's a separate thing. But again, there's like a lot of knobs and dials you can turn to help with this. And the service itself, like the temporal service, temporal cluster, temporal server, whatever you want to call it, is kind of what we're talking about. But Liang, there's stuff on the worker side that people can do as well to help with reliability. Is that correct?
That is correct. Yes. So from worker side and so from worker side, especially, it depends on a few of these things because we usually think of worker as one of just the general application things that our customer does. So it ties back into the sort of the general strategies that company has as it relates to multi-region, as it relates to disaster recovery, because even without Temporal as just a normal service, I think people are already thinking about these things. And different sort of companies and users think about this in different ways. Some of them rely on a certain region to be up, and they rely on different AZ failovers and all these. And certain companies actually rely on failing over between regions. And if you expand that sort of thing into even the teams dependencies, right? People view all these services differently. Like some companies have this concept of global services, so that underneath hood, each team is has the capability of failing those over. And some companies basically rely on some sort of company coordinated events so that they fail over the whole dependency chain.
Yeah. Well, it's interesting, you know, regions do fail. In my last company, I worked at a company, but they had a database that was reliable. And it was funny. It was this bank had 3 nodes it was a distributed database. And they had 3 nodes all within kind of like the Tennessee, Kentucky, Georgia region. And I don't know if you remember, there was like hurricanes or like tornadoes that came through that region like 4 years ago. And they thought they had redundancies, but it wasn't geographically dispersed enough. And their system went down. So, you know, I think taking all these things into consideration is important. So let's extend now. And how do we actually help with regional failures? Because it's something that some people want to get to, right? And, you know, getting, you know, increased number of nines. So Nikita. We've talked about global namespace, I don't know, like 4 or 5, I don't know, 11 times now so far on this thing. What is this thing that we keep referring to?
Yeah, absolutely. And the feature is available in pre-release today, so people interested can take it for a spin. But generally speaking, it's our multi-region kind of availability option in Temporal Cloud that basically provides a way for you to have redundancy across regions. And so what we look at it as is a logical namespace that's kind of running in a primary and a secondary region. And as workflows are progressing in the primary region, all of the history events are asynchronously replicated to the secondary region. So whenever there's any kind of incident, a regional failure or an outage, whether that's caused by a disaster scenario or something in AWS goes down, we're able to fail over the namespace. So all the workflow executions will basically just continue in the healthy region, and new workflow starts are transparently also continued in the new region. And there's no user intervention here. So as a user of Temporal Cloud, there's basically no disruption to your workloads. And yeah, we're really excited about this feature. We have many customers excited about this feature, especially for, mission critical applications that really cannot do with any kind of downtime. So yeah, that's kind of the feature in a nutshell.
Well, it seems pretty easy. Maybe you're just writing data to do places and you switch a DNS when something files. Like that seems pretty easy, but it's not, right? Like it's not as simple as that. So, Liang, there's a whole lot that goes into actually making something that work, right? And so, like, I'm pretty proud of this feature because ultimately, I think Nikita, what you designed is like push button global namespace. Now, there's a fair amount of complexity underneath that, right, Liang? What goes into basically making this kind of reliable, making sure data isn't replicated, making sure failover times are acceptable? Like what goes into this?
Of course. So, by the way, one of the design goals for this whole project is to make sure that people feel easy when they use it. So if you feel this sounds easy, I think we achieved at least half of the goal. Obviously, as with all these different distributed systems, as with the way that deal with different errors, I think it's actually very complicated underneath the hood. Like because we need to deal with different kind of outages and inconsistencies. Like the example you mentioned that we nuke a data center out and we cannot ship anything out probably is the easiest, right? And on the other side of the spectrum probably is the network partition, which I just talked about. For whatever weird reasons, like you have a set of workers that can talk to a part of the network and a set of other workers talking to the other part of the network, while they cannot talk to each other. And then somehow we need to face the trade-off of whether we want to continue to serve partial inconsistent data versus waiting for this whole network partition to resolve. And then there are quite some decisions that we made along the product to make sure that we deliver what we think the customer would want. And while all these events got resolved, we do have a conflict resolution scheme, which brings back all these different pieces of data so that everybody has this consistent global view of what actually happened in the past.
Yeah. And Liang, how much does like, if you take a step back and look at Temporal, like one of the core values of Temporal is like, okay, I could survive like a long running human in the loop where like, I don't know how long this API is going to time out and that sort of stuff. You know what I mean? Like, I mean, the whole context around durability and, if my process fails, I could just, bring it up again and connect it somewhere. Like, how much does the entire concept of like the durable execution play into our ability to deliver something like a regional failover?
So the way I think about this, right, in durable, it's kind of very interesting. Imagine, like you said, there's a long-running operation which lasts for a year, and with all these failovers and redundancies and even region going up and down, what you will see is you start a workflow somewhere in, let's say, US East, one of these regions, and 3 months later, it got moved into US West 2 because that region has outages, and it got executed 3 months there, and maybe it got moved to Europe because of different reasons. And then, I mean, if you look at the lifespan of this workflow, it can land on multiple different regions, while on each of these regions, it knows exactly what happened in the past, and it can continue to make progress. And then this process just goes on and on until we finish this workflow, which completes the user's requirement.
Yeah. Yeah, it's very interesting. I just the durability of distributed systems is something that really piques my curiosity, just because there's so many different things that people can do. And I think this stuff gets really interesting. but it really comes down to how we design our applications and our services, right? And so just at a high level, Liang, is kind of like, you've been designing temporal applications or cadence applications for a long time. You helped build like this kind of build out like how available. What are some of the key things people should just think about as they think about, designing availability into their overall system? Like, what are some of the key takeaways? Beyond just use Temporal Cloud. I'm sorry, but like, what like from
Yeah, I mean, I think in this webinar, we hinted most of these, right? First, it's obviously assume that error will happen. And then always at least think through the impact for these errors. I want people to think about errors as like handling as conscious decisions, like they choose to not deal with these errors, or they are okay with dealing errors in one of these ways, versus they didn't think about this. I think that's the most important takeaway from.
Yeah, I think so. And so then I'll wrap it up with Nikita. There are a couple questions there. If anybody else has questions, please do answer them and get them into the QA and chat. There's a couple that were kind of unrelated to this. You guys, we'll do our best to answer them. But Nikita, we talked a fair amount about global namespace, and I know you're working with a couple of different, customers and just people to use it and to try it out. And let's make. But we got some people using it. Where does it make sense to use global namespace?
Yeah, absolutely. I think we've seen where any kind of disruption would cause, let's say, a loss of revenue, a poor end user or customer experience, wherever there might be some policy or legal compliance requirements for highly regulated industries. So we're seeing a lot of interest there. And if we're talking about specific use cases, I think we can point to payment processing, things like gateways, bookings and reservation systems, even software and infrastructure provisioning and management. All of these are good use cases that you might consider this feature for.
Right. And then, of course, we knew we were going to get this question, Nikita. What's the cost difference between, single region and multiple region for us then? And are you ready to talk about that? It's always a good question.
Yeah, I think it's a fairly straightforward model in that on Temporal Cloud, we're having to replicate all of your workflows from essentially one region to another. So a rough cost estimate might just be like multiply your existing cost per namespace by 2.
Yeah.
And that's entirely due to the cost of replication on our side.
It's 2 temporal service instances with the data. So I think, if anybody has any questions, just reach out to the team. We're happy to talk through explicitly how it all works and all that, right? So there was like one longer question in 3 parts in the chat, y'all, and I'll take the first one really quickly. The first one was all about, you look at scaling cadence or temporal has some challenges. Is there anything that we've done explicitly in temporal as we forked the cadence project to make this easier? I don't know. I know Liang from a cloud point of view, there's a bunch of stuff we do because our control plane just scales for you. But is there anything in kind of open source self-hosted server that's different from Cadence that kind of is amenable to better scale?
I don't think so. I mean, from a scaling perspective, right, the most important is your database system. So I don't know how they scale that part, but as long as they figure that out, the rest is basically stateless.
Right.
So it's relatively easy.
Yeah, without more detail, Aditya, like it's a difficult one to answer, right? Because it's what are the scale problems you have? It's numerous, right? So, and then the next one was state manager. And let me see here. Let's read the.
So yeah, I can answer. I can answer the second one. So for you to, I don't. So couple of points here. The first point is that please don't read all these database events because these are implementation details, and we have all reserved all our rights to change them. And they are actually different if you look at these different database implementations, right? But what you can look into are 2 things. One is these workflow queries where you can just issue a query to a workflow and get state out. The other thing you can do is that we have what we call search attributes, where during the workflow of your execution, you can emit things into Elasticsearch, and you can even get an aggregated view of where you're at from the entire fleet of your workflow perspective.
Right. So everybody, I know we're a little bit time over. We're going to continue to do the QA here, so I hope you all stick with us. But and then the last question there, Liang, was really about latency and what do you around latency when you do use temporal in a
right.
Let me put the question in 2 different ways, Liang. Like just a regular temporal application, what's the latency expectations? And then beyond that, what about with cloud?
Okay, so the way I look at these, right? When you look at temporal added latency, you need to understand, you as a user need to understand, there are even two parts in this question. One is the real temporal server added latency, and the other is related to worker, as like how fast you can pull, how fast you can process, and all these kind of stuff. So and from temporal server side, I think the latency is very low, in at least in tens of milliseconds side of things for of added latency, right? And temporal server even have a lot of projects to make sure that we reduce the latency. All these like the eager activity dispatch, eager workload task dispatch is to make sure we save all these round trips so that you get less and less latency there. But this whole question and problem needs to solve when you look at this entire sort of your worker fleet and everything else.
Yeah.
I guess the question between cloud and on-prem varies a lot. My general impression is cloud has a lot of these optimizations. It actually improved latency, for example, for Stack workflows, right? I cannot speak to this specific task pooling side of things, but usually people enjoy much better latency even from the cloud side. It's a little bit counterintuitive, but mostly because we did a lot of optimizations. That's the first thing, and we over sort of provision the capacity for the entire fleet. Obviously, we provision not just for one use case, we provision for thousands of use cases. So usually the buffer is much more there.
Yeah, that's right. And I'll just do a small advertisement for our session next week, which we're going to talk about the persistence layer that we have within Temporal Cloud that allows us to do some kind of special things and, reach out to our team. We're happy to talk through kind of latency results we've seen with customers where they're, half the latency with Temporal Cloud versus a self-hosted service. I think part of it is some of the expertise we have on our team and how we actually do this, like you're talking about, Liang. And because we're doing it at scale, there's just certain things there's certain knobs and dials we can do a little bit differently. So that's great. So there's a couple other questions. I know, Nikita, you asked the one about, global namespace. Is it available in AWS? Yes, absolutely. And then, there was another question here about sovereignty of data and global namespace. Have we thought about that yet, Nikita? Is that something that we're thinking about?
Yeah, absolutely. We totally get the concern. So at launch, public preview, that is, we will be available within 2 regions in the US. And so, yeah, sovereignty requirements there are solved for. In other regions, we are going to fast follow. So basically tell us where you would like it, and we will respond to that demand. So it's on our roadmap. We're just letting customers kind of drive that decision of which regions we'll have those opened up in.
And always difficult things to do, quite honestly. Data sovereignty is that's a whole can of worms over the next 10 years that I think we're all going to have to deal with. So as regulations change in different parts of the world, it'll get really interesting. So I think we burned through all the questions. I can't find any that we didn't answer, y'all, unless, I don't know, Liang, and I know you guys were looking at it too, but I think somebody was asking, can we publish documentation? Yes, absolutely. Global namespace is something that's coming up. When do we think GA? I don't want to ask you when the GA date is, Nikita, but there's a general sense. It's how far out?
Yeah, so it's called public preview, which means it's production ready. That will happen in a few months. So I would say like in the next 2 to 3 months, you can expect that to be announced, and then GA will follow.
Yeah, and at public preview, we'll publish full docs. It'll be like it's GA. It's just basically in one of those states. And look, watch our blog for more updates on that. We do have some stuff planned around that. So if anybody's really interested in following along or testing it, reach out to us. We'll get you in touch with Nikita. Nikita would love to talk to you, I'm sure, as we go through this whole process of building that out. I do hope that was helpful for everybody. I know thank you everybody for all the questions, but more importantly, thank you, Liang and Nikita, for doing this today. I know you're both pretty busy doing lots of things. So really, seriously, thank you. Thank you, everybody, for the questions. Milena, by the way, on the back end, who looks just like a QR code. Thank you for everything, making all this stuff happen. You can't do any of this, right? So I just get on here and talk. So thank you for everything. So y'all, everybody on the phone, thank you very much. And we'll have a great day. Liang, Nikita, thank you.
Yep. Thanks, everyone.
All right, everybody. Thank you so much.